Here in ArcGIS Pro, we're going to compare and contrast creating a model through the cartographic modeling visual language with statements to produce the same thing in map algebra. And what we want to do here is turn this particular elevation layer into a layer of slope so that we can convert elevation to slope. Using a tool, so if I click on my tools under the analysis tab, it'll bring me to geoprocessing. And then I'll click on toolboxes. I'll go down to spatial analyst tools. And in here, we have a surface set down there. And in the surface, we have slope as one type of function that can be used on a single layer. Next, I'm going to go to catalog and we'll build a cartographic model to do that. This particular elevation layer is in feet right now. It's in the state plane coordinate system, and the elevation is in feet because it's in the United States. It's a DEM from the United States. And so we need to convert feet to meters before we compute slope. So we'll create a cartographic model. To create a cartographic model, we click on the catalog tab, and we have to create a toolbox somewhere. And I'm going to create a toolbox in the same folder that my data is. That just makes things easier. So I right click on the folder data and I say new toolbox. And it asks for a name. I'll call this my toolbox. Like so. Or you can leave the default name. Then we need to add a model in here. So I'll right click on my toolbox. I'll go to new model. And this will open up a model window to replace the pane called map, or beside the map pane, I should say. So here we have a model window. With the model pane open, I'm going to drag in elevation right from the contents pane and drop it here as an input. Now, elevation, that represents now the layer elevation that we see on the map, but within Model Builder. And I'm just going to move it over here. I'm going to zoom in a little bit, just so things are larger, easier to see. And I just use my mouse wheel for zooming. Next, I'm going to go to my geoprocessing math times. So in the spatial analyst toolbox, you go down to math, and then you'll find times and drag that in. And here we have a disconnected process. Remember, every cartographic model process has three things: an input, a function or operation, and an output. So we have an input that's not connected to an operation. So to connect it, we just click on our select button up top within the Model Builder tab. And that's automatically a tab that's there when Model Builder window is open. And I click and hold my left mouse button down on elevation, and you'll see an arrow up here. And as I get closer to times and bring it on top of it, I can release. And it will ask me now for the parameters of times, the tool, the operator, what should elevation be? Input raster or constant value 1, or input raster or constant value 2. Since multiplication, it doesn't matter what's first or second. For convenience, I'll say elevation is input raster or constant value 1. Like that. This is now a process which is in a non-ready to run state, because we have only color within the input and the rest of the tuple, the three things, the times and output raster, are gray. So it's not ready to run until it's all colorful. Why isn't it ready to run? Well, times requires something to be multiplied by something else. And right now we just have elevation. So what will we multiply it by? Well, we want to convert it from feet to meters. So I'll double click on times, and that will open up the parameters for that tool. Elevation is already there in the first box. So in the second box, I'll put 0.3048, and that will be the multiplier. And then it automatically puts that there. And you can move things around if you want them to look a little, like you can have that and this down here. Oops, sometimes it's hard to get the mouse to move properly. And it's also all a very good idea to rename these things. So we know that elevation is an input. It's going to be multiplied by what? So I might change, right click on input raster constant value 2 and rename that to 0.3048, like that. That way I can read this model much easier. I know that elevation times this is going to happen. I could even be more explicit. I could click on elevation, right click and say rename, elevation, and then I could put FT for feet to remind me that elevation is in feet times 0.3048. And the output I can rename here to elevation meters, like that. Now, this model, or process, single process, the atomic component of a model, is now in a ready-to-run state because all of the inputs, the geoprocessing functions, and outputs have color. Blue for inputs, yellow for functions from the toolbox, and green for outputs or intermediate outputs. So if I was to run this right now, before I run it, I'm going to click on the output, right click and say add to display. And that will ensure that the output is added to the display when I run this model. Before running it, I click save. You should frequently click the save button every time you make a minor change to your model, just in case there's a crash. If there is something wrong with your model, you won't be able to get it back. And again, these can grow quite large visually, quickly. So let's just run it for now. I'm just going to click run. And it's executing it. And it tells me here that it's done, and gives me any details if there was an error or anything. So I can close that now. And you can see elevation M right here has been added to the contents table. So if I go back to my map window here, I can see elevation in meters. It goes from 133 to 1,329 meters. Going back to the model window, that was just an example, and it now is just to show you that this model is in a has been run state. Notice that there's shadows, drop shadows underneath times and the output elevation. That tells you that it's already been run. I can validate the model to put it into a ready to run state again. You can't run a model that's already been run, that's in an already run state. You must revalidate your model to put it into a ready to run state again. Now, that elevation in meters then could be used in the process to create slope. So now if I go back and I find slope under the surface toolbox of the Spatial Analyst tools, I can drag in slope, like so. And now that I've created a layer called elevation meters, I could drag that in as input to slope. But that would defeat the purpose of creating a cartographic model, because here I would just have two processes that are being run separately. And in fact, the second one can't run unless the first one's already been run. So instead of that, we compound these processes. So I'm going to click on elevation and connect it to slope as the input raster. And now we have a cartographic model. And I can organize that differently if I want. I can just select those things, move them up over here, maybe zoom out a bit to see that complete model. So elevation in meters to slope, and then the output raster here, and I want to have that added to the display, and I'm going to rename it. So I'll rename that as slope. Oh, I can't do it, it says. The name is already used by another element in the model. Please enter a unique name. So when you see this error, you will know that you can't use what's called reserved words in your model. That is, don't name things that you're allowed to name, like outputs, by the names of the tools you might find in Toolbox or any tool in Toolbox. So here, I'll call this instead slope out, like so. And right click and make sure the add to display is on. And in fact, in this particular model, the elevation meters doesn't need to be added to the display because it's an intermediate output. It's not something that we want or need to see. All we want is to put elevation in feet in, and out comes slope. So that's an intermediate layer. And I just showed you the run of it originally to show you how it could run as a model by itself as the first tuple. But so now we have two tuples together, and this model is ready to be run, so I can validate it and run. And it shows us what's happening. If we watch, red means that process is happening. Now slope is happening. And then when the drop shadows come on, we know that it is complete. Click save. Should have saved it before running it, but I forgot. And then back on the map here, there's slope. And here is the visualization of slope, the default, and that goes between theoretically 0 slope, flat surfaces, to less than 90. We can never have a 90-degree slope. It's undefined. So very close to 90. So that's the cartographic model. And I can click save. If I want to save that, I'll just validate it again so it's ready to be run next time. And now I can close the model and save changes. The second way we could have done that, and you can see it's very fun. Model Builder is very fun, and there's nothing wrong with using it. But even that one became a bit large, didn't it? You know, with just two processes. So instead, I'll go to Python. So I'll open up my Python window here. So now that I have the Python window open, the first thing I'm going to do is import the spatial analyst functionality so that I can use it in Python. And to do so, I say from arcpy.sa for spatial analyst, import all, which is the asterisk. So now I can use all of the tools in the spatial analyst toolbox as functions within the Python window. The next thing that I'm going to create or make a statement here is to import the environment settings. I'll say from arcpy import env. Env is a class that we can use to change things. Anything that you see in environments right here in the analysis tab. So now I have access to all those environments, but just for the Python window. So if I use a statement such as env.overwrite output equals true, like so, that ensures that within Python, if I want to use the same output variable name for a raster more than once, I won't get an error saying that that raster already exists. It will automatically just replace it. So this environment setting right here applies only to Python. Environment settings that you apply in Python stay in Python. They don't affect anything else in ArcGIS Pro, such as toolbox functions that you use through the toolbox or anywhere else. Now, these statements here, you only have to do them once per session. This is my first session of Python in my first session of ArcGIS Pro for today. So I put these statements in there. And as long as I don't close and reopen ArcGIS Pro, I don't have to say them again. They'll be there and continue to act no matter what I do. The first thing I'm going to do now to make my equivalent map algebra statement is to create a variable called elev, and I'll say elev equals raster and then elevation times 0.3048. So that creates a layer called elev that's in meters instead of feet. Next, I can just create the slope. I'll say slope out 2 equals slope in parentheses elev, my raster variable, like so. And that will be identical to the previous slope. The difference being that the automatic legend that is created between the two is slightly different. To ensure that they're actually the same, or to prove that slope out 2 and slope out 1 are the same, I'll do a difference map, and that should be 0 or very close to 0 within numerical precision everywhere. So I'll just say D for difference equals slope out 2, which is already a raster variable, minus raster slope out, right here. And here we see then D is 0 everywhere. I'll just close my Python window to show you that. So that's D. So it's showing that all the cells for slope are the same, whether we do the two operations within a cartographic model or as two statements like that in map algebra. Of course, the advantage of map algebra is I could have done it all in one statement. So I could have done this instead. I could have said elev equals raster, just to create the raster variable from elevation. Then in one statement, I could say slope out 3, for example, equals slope, and then in there, elev times 0.3048. So that's a single statement using map algebra. So I create what's called a raster variable first to hold a reference to the raster called elevation in the raster variable called elev. And that's done by using the raster function. Once I have the raster variable, the reason I make them is just because it's easier to type out a raster variable every time than saying raster and then the name or the path to elevation. Now I say slope out 3 equals slope elev times 0.3048. And notice I did that inside the parentheses, which is fine. Python knows to do that first, to multiply elev, which is just the elevation raster in feet, by 0.3048, and then take the slope of that. So in many ways, although I've showed a number of ways of things here, it might look long, it's very quick to do things as statements in map algebra compared to creating a model. And you'll see that becoming more clear as we look at more advanced examples that come up.